Good morning, good evening, or good afternoon, whenever it is you're watching. Thank you for watching, first off. Today's topic is going to be 2.14 chemical change. This is the assignment for Wednesday, October 14th. Remember, grades are due on Friday, guys, Friday the 16th. All right, so I'm working here with fifth period. They're a great class. I wish more. And they're gonna help me out with today's assignment. And we're gonna start talking about, do you like to cook? All right. So who's gonna help me with the introduction? Any volunteers, or do I have to volunteer somebody?
I will.
Thanks, Oscar.
Cooking is a valuable skill that everyone should have, whether it is a simple grilled cheese sandwich or preparing an elaborate meal. Cooking demonstrates some basic ideas in chemistry. When you bake bread, you mix some flour, sugar, yeast, and water together. After baking, this mixture has been changed to form bread, another substance that has different characteristics and qualities from the original materials. The process of baking has produced chemical changes in the ingredients that result in bread being made.
Thank you, Oscar. So, if you've ever cooked food, whether it was maybe eggs, breakfast, potato and eggs, bacon and eggs, whatever it is, you have probably, or you more than likely have done some type of chemical change to that food, right? Whether if it's breaking an egg and making that liquid into a solid, ready, hot, nice, and ready for you to eat. You have done chemical changes throughout your life, right? And even grilling, even just doing a grilled cheese sandwich or preparing a three-course meal, you can understand chemical change. And what do we mean by that? Well, they gave us an example about baking bread. Anytime you bake bread, guys, you're bringing a lot of ingredients together. In this case, you're bringing flour, sugar, yeast, water, and maybe some oil, maybe some eggs, I don't know, milk. It just depends on the type of bread you're baking. Now, when you put them all in a bowl and you start to mix, you're only mixing them physically. You haven't chemically changed those substances. Now, once you prepare your mixture and you put it in a pan and then you put it in the oven, that's when the chemical change starts to happen. Okay. When you add that heat, you are chemically changing all of those ingredients into this nice, fluffy, tasty bread, right? That is a chemical change. Why? Because those ingredients are gone. Once you've applied that heat in the oven and changed it into bread, you have created a new substance. Those ingredients have chemically combined to form this nice baked bread. And chemical changes happen all the time, and even inside our body, not just when we're cooking, but anytime you breathe. Okay, we're going to be talking about those because that's the main idea for today: changing things, substances on the chemical level. All right, so let's talk about chemical change. Most of the elements we know about do not exist freely in nature. For example, sodium. Sodium cannot be found by itself because it interacts easily with materials. And we saw that. We saw a lot of group 1 metals in a video, I think it was last week. They were combining all of these metals with water. And that first one that we saw was lithium. Lithium, when you added it to water, releases a hydrogen gas, and we're able to see that. And the further and further down we got on the periodic table in this group, sodium reacted a little bit more energetically, potassium a little bit more, rubidium a lot more, and cesium, I think, broke the glass that the container was in, that the water was in. Okay, all of those were chemical changes with water. Okay, all of these group ones. Um, the only time you can get sodium by itself is if you prepare it yourself in the laboratory. Okay, and that's you helping it, you breaking it apart under certain conditions and storing it. On the other hand, the element helium. Helium is a noble gas. It does not interact with other elements to any extent. So if you look at the periodic table, helium is on the opposite end of sodium. It's in group 18. Something that you need to know about this group 18, is that all of this group is non reactive. Just like they said that helium does not bond or combine with other elements at all. The same thing happens for neon, argon, krypton, xenon, and radon. All of these noble gases are what we like to call complete as far as the electrons it needs, okay? If you have 8 electrons in that outer orbital, you have a complete set. You don't need any more. You don't need a bond with anybody, okay? You do not need a bond with anybody. That's something special about this group 18, these noble gases. If you're looking for helium and you want to extract it, you can isolate helium from natural gas during that process of drilling for oil. So if you have an aunt or an uncle or a dad or an older brother and they are in the oil fields drilling for oil, more than likely one of those products that they're drilling for is helium. Okay? Helium. And that's just one compound or one element. A chemical change. This is the actual definition of a chemical change. A chemical change will produce different materials than what you started with. Okay? So if your substance that you have has undergone a chemical change, it is completely changing into something new with different properties and different characteristics. One example that always comes to mind is when you're cooking out, right? And we do that a lot. We do that a lot, especially right now during football season. My dad, and I'm pretty sure all of our dads or uncles, they like to cook out when there's a football game on during the weekend or maybe even during the week. But when you're preparing that cookout, one of the first things you're gonna need, or one of the first things that people use, is mesquite wood or charcoal. When you throw in that charcoal into your barbecue pit, it's gonna have a certain color, it's gonna have a certain texture, it's gonna have certain properties. Now, once you get that lighter fluid, you spray it around and you throw the match, it's going to get on fire. Well, if you remember Monday's assignment, Monday's reading, we talked about 4 indicators, four clues to let us know that a chemical change is happening. One of those clues, you see it when when you throw that match and it lights on fire. You see that fourth evidence of a transfer of energy, right? You can put your hand close to the fire and you can feel the heat that's being released, that energy that's being released from the wood or the charcoal. That is an indicator that a chemical change is happening, a chemical reaction. Now, after the barbecue ends and mom or uncle or dad or brother has finished barbecuing, well, you're going to see a change in color. A change in color is another indication that a chemical reaction has occurred. The release of heat was the second piece of evidence that a chemical reaction has occurred. And if you look at that ash, it's going to have different chemical properties than the wood or the charcoal that you had before. What's the color, right? If it was charcoal and it was black, does it still look black after you've done a barbecue, Oscar? What color is that ash after it has been burned?
Black.
It looks
Right.
black. Doesn't it look kind of like a grayish color?
Oh yeah, the coal.
Well, right. Before it looks black, right?
Yeah.
But after you've burned it, what's the ash
starts
gonna
getting-
look?
It starts getting like grayish.
It kind of
like
gets like a
gray,
gray, white kind of color, right? Remember,
Yeah.
color change is an indicator that a chemical change has occurred. And the same thing would happen if you had wood, mesquite. It's gonna look, brown or maybe even a little grayish color, but it's not gonna have the same properties once Oscar has done his barbecue, right, Oscar?
Yes.
Thank you, sir. Where were we? One aspect of the science of chemistry is the study of the changes that matter undergoes. If all we had were elements and they did nothing, life would be very boring. In fact, life would not exist since the elements are what make up our bodies and sustain us. Now, what kind of elements are in our bodies right now? What are we made of, guys? What are we made of as humans?
Water.
Water. What elements are in water, Oscar?
H2O.
Hydrogen and oxygen. Those are two elements. And our body is what, like 80% water? So, what if those elements didn't chemically combine? Would we still be around, Oscar?
No, we wouldn't be alive.
We wouldn't be alive, right? If that water if that water did not combine, if hydrogen and oxygen did not combine chemically to form water, we as humans would not be there. When we breathe, what do we breathe, guys? What do we breathe? What did I just breathe in as I took that big deep breath? What's going inside my lungs right now?
Oxygen. Air.
Air, oxygen, right? Now, as I breathe out, is it still oxygen?
No, it's carbon dioxide.
It's carbon dioxide. A chemical reaction is happening in my lungs, in your lungs, every single time you take a breath. Well, what if that reaction didn't happen? What if oxygen doesn't change into carbon dioxide? Would we still be around? No, we would not. If that oxygen doesn't go into our body and change into that carbon dioxide would stay and it would kill us. Okay? We have to even out whatever energy goes in, the same amount of energy should go out. But the processes of change that take place when different chemicals are combined produce all the materials that we use daily. Okay. One type of chemical change that we already talked about, we talked about it on Friday. When we have two elements that combine to form a compound, we call that a synthesis reaction. If I have hydrogen gas and oxygen gas and they react, they form water. Another type of reaction is when compounds break to produce elements. So if I have water and I pass electricity through it, it will break up those two elements into hydrogen and oxygen gas. And we saw an example of it last week. If we pass electric current, if we hook it up to electricity, aluminum oxide or bauxite, we will get metallic aluminum as a product. And here you have a picture of that happening. Look at that giant machine that they were using back in the day. They made sure that that giant machine passed through current through that aluminum oxide, separating the oxygen from the aluminum and leaving that nice shiny metal that you see at the bottom of the page. There are a vast majority of chemical changes that involve one compound changing into a different compound. There are literally millions of possible ways to approach this chemical change. I can almost rearrange compounds, two different compounds, by doing that switcheroo. Remember when we talked about double replacement reactions? When you have two couples, two compounds, they can switch partners and create new compounds, right? That is a double replacement reaction. And double replacement reactions have millions of possible ways to do this exchange of elements to create new compounds. New compounds can be produced to make better fabrics that are easier to clean and maintain. A lot of the fabrics that we have, all we got to do is spray that shout, right? Every time that Oscar goes to practice and brings those dirty, dirty socks, right? Because he's been practicing so hard, his mom is going to be like, ay, no, estos estaban blancos, ahora están negros, Oscar. ¿Qué estabas haciendo en el football field? Pues estoy practicando, mom. You know, that's what he's going to say. He's like, I'm practicing, mom. I'm not worried about how dirty my socks get. So ahí está, Oscar's mom. Spray, spray, spray. Let that soak. Put some Clorox and bam, they're white again. Okay, that we have created different substances to help us clean our dirty clothes. New compounds can also make food last longer so that it doesn't spoil as quickly. We call those preservatives. If you've ever gotten canned vegetables or canned fruit, there's a lot of preservatives, a lot of well, not chemicals, but substances to help that food not go bad as fast. Um, New compounds can make new medicines to treat disease. I was reading about Johnson and Johnson, the company, having to stop its experiment or its study on the coronavirus vaccine. Why? Because one person out of 60,000 people had a bad reaction. So now they're saying, hey, the FDA is saying, stop Johnson and Johnson. I want you to stop the study and I want you to find out if any other person is having this negative reaction because those negative reactions can be dangerous. Okay? Even products such as airbags have used chemical change to inflate and deploy that airbag so we don't get hurt in a car accident. And that's what we're going to be seeing right now in this simulation. So if we have a test dummy, how does a chemical reaction inflate an airbag? To protect drivers on the road, most cars have airbags. They come out of the steering wheel by a chemical reaction. There's a sensor in your car that will detect when your speed changes all of a sudden. It will then have an electric current. You see the electric current? Pass and change this compound that's sitting inside the canister. And it's going to change it from probably from a solid to a gas to inflate. And it usually happens in 0.03 seconds. All right, let's see what's happening. Can you make a chemical reaction that will help inflate the airbag in time to protect this person? All right, so let's look at the graph. The graph uses time as our x, volume as our y, and we can tell in order to get that airbag completely filled to its maximum so that the person stays safe, it needs to be between 50 liters and 75 liters, and it's probably closer to about 75. I would say about 70 liters that airbag needs to be filled all the way. So we have three chemical compounds: sodium azide, ammonium nitrate, and nitroglycerin. All right, so let's look at this first one. Sodium azide is an ionic compound used to aid in the inflation of things like airbags and escape ramps. So, have you ever seen a movie where the people all of a sudden are getting out of an airplane in a slide? That's an escape ramp. Okay? And sodium azide is one substance that they use to produce a gas to fill up the airbags and this ramp. All right. So right now we only have 1 mole. 1 mole of this compound. Let's see what happens. Is it enough? Was it enough, guys, to save this crash dummy?
No.
No, look at how big. It's very small. It doesn't even cover the whole steering wheel. The person actually was hit by the steering wheel. Guys, sometimes just that simple hit can kill somebody, especially if it's really, really hard. All right, so let's change it. Let's change it. Instead of having 1 mole, let's change it to 2 moles. Let's double the amount. Look at that. Just enough volume goes into the bag to produce, to help save this person. All right, so that's one compound. We need to make sure that there's always double the amount. If we have an ammonium nitrate, let's see what ammonium nitrate. Ammonium nitrate is, if it's heated enough, it will naturally decompose. However, this is not an explosive reaction. All right, so it's not a reaction that's real violent that can hurt people. Let's try 1 mole before we double up. As you can see, does the crash dummy get saved?
Yes.
It sure does, guys. It's enough. 1 mole. Let's see if we double it. Will doubling it make it too much? Oh, yeah, that's too big of a reaction. The airbag explodes and the dummy hits the steering wheel. All right, let's talk about nitroglycerin. Nitroglycerin, what is it? Nitroglycerin is a highly explosive compound found in dynamite. Uh-oh, this might be too dangerous to use. It is used in construction, demolition, and the mining industry. Nitroglycerin is a great gas producer, but it also is shock sensitive. So I don't know if we really should use this one. Let's see. Way too big of an explosion. Way too big. It could probably hurt the person more than the car crash. I don't even want to think about what would happen if it doubled. Let's see. Wow. Again, way too dangerous. Way, way too dangerous. All right. So this is one that we will definitely not use for chemical, for airbags and inflating them. It can be very dangerous. All right. So we're done with the simulation. We're done with the lecture. Let's summarize. A chemical change produces a different material than the ones we started with. What and your review questions, what is a chemical change? And list 3 types of chemical change. Answer the questions, guys, and turn them in.